So we need to learn to do factoring by grouping, and this is the only method we have to factor a four-term polynomial. In this case, in this class rather, we always factor by splitting it in half. We always factor with 2 and 2. In the next class or classes after this, there's a little bit more variation on the theme, but they'll talk to you about that. Right now, we just want to focus on what we know, and that is we've got a four-term polynomial, so we're just going to split it in half. So when we do that, we go ahead and split it right here, and you'll notice that I also, make sure that the sign here goes with this term, because the sign in front goes with the term. Now, in your book and all the videos that you see for the publisher, they're going to put parentheses on this. And I don't like using parentheses because the parentheses can be a little bit deceiving. Sometimes the parentheses have people forget about the plus and that middle term that I was just referring to. And sometimes it has a few other things that makes people think that they're supposed to be multiplying because they've got two parentheses next to each other. So it can be a little confusing. So I just use these little swoopy things to make sure that we can see. Now, the first thing that we see is we've got a greatest common factor on these first two terms. This is our group. So we see we've got a 3 and a 6. So our greatest common factor there is 3. And when we divide it out, when we divide 3 out of each of these, we're left with x plus 2. Now the next thing we do is we always bring this middle sign down. So since it's a plus, we bring the plus. And now we see in these two terms, we've got a greatest common factor of a. And now we divide it out. And remember all those things that we did with GCFs, the same rules apply here. We're just doing it in the middle of sort of a bigger context. Now that we divide out the a, we're left with x plus 2. Now this should look familiar because I did some examples that looked like this because I wanted to prepare you for this. And you'll notice that we are now down, we did have 4 terms, and now we're down to 2 terms. And in these 2 terms, you can see our greatest common factor is x plus 2. So we're going to divide x plus 2 out. And then we take what's left over, which is our 3 and the a. So we do a 3 plus a. And you'll notice that I'm always dragging that sign with. We can't just leave it. Now, this is one of those things that people kind of look at and they think that we're all, it's some magic trick. And it's not really a magic trick. And I want you to really go back and FOIL this out so we can see. Here is our factored form, and I'm just going to write it over here so we have a little bit more room. And now we're going to FOIL this thing out. We need to really believe that this works. So x times 3, x times a, and I write it ax just because we like it alphabetical, 2 times 3, and 2 times a. Now we look at our original, and our original looked a little bit different. I'm going to bring it down here so we can take a look. Our original looked like 3x plus 6 plus ax plus 2a. Now if you look at these two things, you can see the 3x is exactly the same, and the 2a is exactly the same. And by that I mean they're exactly the same, and they're in the same position. Now on the first one, we have a 6, and the second one, we also have a 6. So it's just in a different position, and here we have our ax, and here we have an ax. So all the terms are exactly the same, they're just in a slightly different order, and that's okay, it doesn't matter. Remember, the order of the terms doesn't matter when everything is adding. So this is okay, and we've proved that it works. Okay, so let's look at this one. Here we've got something that is sort of counterintuitive. We see that we've got something that they look like terms, and indeed they are. Now this is the one time where I'm going to tell you that when you see you've got like terms, you're just going to need to leave them alone for the four-term polynomials, because these are an exercise, again, to get us used to something that we're going to use and see a little bit later. So we see we have a four-term polynomial, and the first thing we do is split it up. And in the first term, we see that we've got a greatest common factor of m. So we divide that out and we get m plus 6. We always bring that middle sign. And now our second set here, we've got a greatest common factor of 2. And then we divide that out. And of course this makes us very happy because we see we have the m plus 6 as our new greatest common factor. And then the leftovers, because remember we're dividing it out, go into our second parentheses. Now let's say you did this and you're like, okay, well that's all right, but it's not in proper form. Well, this one is. The reason I kind of want to talk about this is because this one is in proper form. I'm going to put it out of proper form just because I want you to see this little idea. Let's do. So I just switched the first two. So greatest common factor is m. We divide it out. We're left with 6 plus m. Keeping that. Greatest common factor, again, is 2. And we're left with m plus 6. Now you see what's happened here is the order of these terms isn't the same. But again, that sort of goes to that same idea that we talked about in the last bit, and that is the order of the terms doesn't matter. So this is the same, and m plus 6 is the same as 6 plus m, so you just take that m plus 6 that you see as your greatest common factor, because these are indeed the same. And we write the m plus 6 just because we like to have our variable first, and then the leftovers again. So sometimes you rewrite things, sometimes you get things in different order. You can't let that be something that sort of stalls you out a little bit. You just have to reorganize it and rearrange it a little bit. And so let's do another little example here. And we've got, again, a four-term polynomial. So we know the first thing we do is split it. We look at the first set and we see that there are no like terms. Now, in a four-term polynomial, when there are no like terms, we want to write 1. No, greatest common factor, rather. So we just write the 1 as our greatest common factor. And then, of course, we have the plus that we bring down. There is an x in both of these. So that's our GCF. And when we divide it out, we're left with 3x plus 2. Now what we notice here is these are not the same. Now that does not mean that this is not factorable, just because the stuff in the parentheses isn't the same. So what we end up doing is trying to rewrite it. Now when we look at this one, we see that it isn't in proper order. So let's go ahead, and the first thing that I will try to do is to put it into proper order to see if that works. So that's just my first option. So now I'm going to look at this and say, all right, there's 4 terms. I'm splitting it in half. In the first 2 here, I see I've got an x squared. I divide that out. I'm left with x plus 3. Bring in this sign. And here I see that I've got a 2 as my greatest common factor. I divide that out. I'm left with x plus 3. This makes me happy because now I've got a greatest common factor of x plus 3. And in the second parentheses, it's the x squared plus 2. And of course, the next thing you should do is multiply it back to make sure that you got done what you needed. Again, the key here is, what we've hopefully taken away from this bit is sometimes you have to rearrange the terms to make it work. Now, in this case, it just worked immediately as soon as I put it into proper form. That's not always going to be the case, but really there are only 4 different ways that you can rearrange these that make sense. So you will, it doesn't take forever, but you do have to do a little bit of work for it sometimes.